These are all going to be, most of them will be decimals. Okay. Yeah, I would say just round to say 3 decimal places is good. But it's really not that important. We're just going to use this to kind of help us as we graph. So, well, I think 2 decimal places is good enough. 2 decimal places is good enough. To two decimal places. So again, all these values are coming from the fact that we are taking the reciprocals of sine. So 1 over 0, 1 over 0.5, 1 over 1. And then after pi, you're going to see a bunch of these repeat values, but now we're going to be in the negative region. Okay. We're not going to plot those points just yet. We're going to focus our attention on the sine graph. But I'm not going to have us put all those values for the sine graph. We're used to just the basic or the 5 number or the y values from just the most important points. So take a moment, see if you can just do 2 periods of the sine graph. But as you graph the sine graph, connect all the dots using dotted lines, okay? Because the sine graph is not really the graph that we're after, but it will provide a very nice boundary and allow us to know where to put the cosecant graph. Okay. Again, I'm just going to, I'm going to identify the important values though. So pi over 0, pi over 2, pi, 3 pi over 2. Okay, so that's 1 period of my sine function. I'll repeat the process. Okay. So here's 1 full cycle. Repeat the cycle again. Okay. Again, the sine graph is not what we're really after, but it will give us a very good way of knowing where to put our cosecant graph. Okay. Now, there is something that we haven't seen before with sine and cosine graphs, and it's these undefined. Right? So what it means with undefined is we're now going to be seeing some vertical asymptotes in our graph. So we're going to place vertical asymptotes wherever we see this undefined. Okay. And a quick way for us to know where these vertical asymptotes are going to be lined up, they're all going to be lined up wherever your sine or cosine graph, because we're going to do cosine for secant, wherever our graphs hit the x-axis. Wherever it hits x-axis, that's going to be where these asymptotes occur. But in a more general way, it's basically where the graph crosses the d value. Okay, right now our d value is 0, but once we shift the graph up or down, right, that d value is going to be the new center of our graph. So whatever our vertical shift value is, that's going to be where wherever that value crosses the sine graph is going to be where your vertical asymptotes will occur. So you see vertical asymptotes at 0, at pi, and at 2 pi, and then we can also figure out 3 pi and 4 pi. So what we're going to do is we're going to just see if we can draw vertical lines to indicate further boundaries that we'll use to create our cosecant graph. Okay, any questions so far? So all this time, we haven't graphed anything with cosecant yet. We're still creating our boundaries for cosecant. Okay, so now we're going to plot these y values from these radian measures here. So you're going to see this grouping of three x values. So these are going to be the special angles. So you're going to have pi over 6, pi over 4, and pi over 3. So all the middle ones will be with the 4 in the denominator. Anything that's closest to the x to the asymptotes will be a family of pi over 6. Anything closest to the middle is going to be your pi over 3s. Okay, so starting at pi over 6, I'm going to be plotting a y value of 2. So it's going to be all the way up here. Next up, at pi over 4, I'm going to be at 1.41, so that's a little bit under 1.5. And then finally, let's see, pi over 3 is going to be at 1.15, so it'll be slightly above 1. And then at pi over 2, it's going to be at 1. Keep going. 2 pi over 3 will be at 1.15, so we're kind of creating this mirror image here. Next up, 1.41, and then at 5 pi over 6 is going to be up at 2 again. So if we connect those dots, what shape does that look like, you think? In the shape of a what? Yeah, kind of parabola, right? Yeah, U-shaped. So what's going to happen is this is basically what your cosecant graph looks like. It's basically between the asymptotes, and it is bouncing off of the peaks or valleys of your sine graph. Okay, so likewise, we can do the same thing with the region from pi to 2 pi. So 7 pi over 6. Now we're going to be plotting in the negative region, so negative 2. Negative 1.41, negative 1.15, negative 1. So once we have that, we have a full complete cycle of the cosecant graph. We can repeat the process. This time we don't have to worry about the decimals. We can kind of we have an idea where it's going to go. It's going to hit a minimum at 5 pi over 2, and it's going to kind of hug along the asymptotes. So really, what we're going to do for these graphs, we're going to spend most of our efforts either graphing the sine or cosine, and at the very end, we'll build in what we're really after, which is cosecant, or we're going to see secant on the other page. All right, any questions so far? Okay, let's see if we can answer some of these questions here. The period, what do you think the period, what's the length of the full cycle of cosecant? Or how long will it take for cosecant to complete its cycle? 2. Yep, 2 pi. Yeah, because once after 2 pi, it starts to repeat itself, right? So it's the same cycle length as the sine graph. Okay, domain. Domain is where the graph exists, reading from left to right. Okay, it's basically all real numbers except what? Is it all real numbers? It's close, but do we see any places where the graph does not exist in terms of the x value? Yeah. Yeah, yeah. So we see all these asymptotes, right? So we have to say all real numbers except the asymptotes. So we can say all real numbers except, like you said, intervals of pi. So you've seen this notation before where we say pi n. So that indicates it could be 2 pi, 3 pi, 4 pi, or it could be in the negative direction, negative 2 pi, negative 3 pi, negative 4 pi. But we have to indicate that n is an integer. So those are all the places where the graph can exist in terms of the x values. What about the range? What about the y value? Where does the graph exist from a y value perspective? Okay, so starting at the lowest y value, we definitely have negative infinity. When we say negative infinity to positive infinity, okay, there's a break, right? How far does it go before that break starts? To -1, okay? So that's one piece of it. Anything special about -1? Yeah, bracket, right? Actually does reach that point, so put a bracket there. Okay, it skips a little bit, and then it picks up where? +1 to infinity, okay? And then again, bracket around 1. Okay, so that's our range. Okay, any questions here? Okay, so here are some tips for graphing cosecant functions. First, plot your points like as if you're graphing sine. Basically just you're ignoring the fact that it's even cosecant until the very end. We'll have vertical asymptotes wherever you see points on the x-axis. Or later on, we're going to see really it's going to be the intersection with your d value. It's going to be the intersection with your new center, wherever that is. Okay, you're basically going to be plotting parabolas at the peaks and valleys of your points, so at the max and mins. And then the max points of your sine graph is going to be where your parabola is going to open up. And then the minimum value of your sine graph is going to be where your parabola-shaped cosecant graph is going to open down. Okay, any questions there? So knowing what you know, we're going to see if we can create the secant graph, which is based off of the cosine. So on page 17, we're no longer going to rely on the table. See if you can identify the major points of the cosine graph, graph your cosine. Remember, cosine starts at the peak and makes its way down. You'll use dotted lines along that cosine graph. Wherever your cosine graph hits the x-axis, that's going to be where your asymptotes are going to be. And your secant graph is going to look a lot like your cosecant graph. It's just a shifted version of your cosecant graph, just like how cosine is a shifted version of the sine graph. So a lot of things will look the same, except your asymptotes will be a slightly different place. All right, so page 17. See how much you can do with the graph. But it says graph cosine theta in one color, graph secant in another color. I'd rather just have you guys do cosine using dotted lines, and then solid lines at the very end for your secant. Okay, let me see how you guys do, and it should feel like review, right? You guys just got done taking sine and cosine. Get the asymptotes in place in this section. Graph the cosine graph. This is not one. The sine graph is just going to be an outline. So after you graph your other lines and your asymptotes, cosine graph is really just these. We graph the sine to kind of help us put all this side.
Okay, so here is
well, we don't care about the sine, so we raise the sine. Because we want to graph. So wherever your sine graph, cosine graph, is the x-axis. It's going to be where these asymptotes will occur.
like that.
Yeah, just like this. And the true graph is really just these parabolic bouncing off the route. Okay, but it's not like this. It's going to be where the graph crosses the x-axis. That's going to be your
Oh, I thought. Oh,
It's not exactly the same. So, yeah.
So then what do you do? You just graph this.
And then you just graph parabolas. Graph parabolas off here. But you want to stretch it further out because you want it to go along. So the asymptotes kind of help guide how wide your So maybe but whatever these x-intercepts are, these are going to be help you guide how wide those asymptotes.
Oh.
See how all the whenever it hits the x-axis, that's going to be where my asymptotes are. Once I have my dotted lines all in place, I graph my parabola.
Is that it?
These dotted lines.
Yeah.
This is not really the graph. The graph is really just these parabolas, but these are how that's
And then you fill these out.
well, this is just, we're going to do domain, we're going to fill this out. And then put that back on. I can ask the cosine graph. What's the cosine graph? Where's the cosine graph stuff? This? Starts at number cosine system starts at 1, after 0.
Because the thing is, it's basically sine except for
What you graph here, you graph the sine graph. You're not
yeah. It's basically sine except for square. Yeah.
Oh, that's what you said.
Cosine starts at a P. That was like a couple.
So this one, we can do that. So 1, 0,
I'm not.
okay. So once you have this graph, now we can build some parabolas. This parabola is livable. That's really the Cosecant graph. Okay. So here it's a little strange because it doesn't, I was not gonna, I guess we probably could here. The world really just gonna because starting at here.
Yeah.
Well, it's not, you need to. Not flip the book.
Technically, we could finish it out if you want. I would like this go.
Yeah, but, well, I know, I was just taking a minute break.
Okay, so let's check our graph. So we start off with the cosine graph, right? Start off with the cosine graph. You know what a cosine graph looks like. It starts at the peak, hits 0 at pi over 2, hits the minimum at pi, back to 0 at 3 pi over 2, and then back over 2 pi. So we're just creating the cosine graph. And then wherever the cosine graph intersects with the x-axis, that's where you're going to start, you're going to drop your vertical line. That's going to be where your vertical asymptotes will be in preparation for the secant graph, which is what we're after. And then once you have all that in place, then you're simply drawing your secant graph, which is really going to line up between the asymptotes, and it's going to bounce off of the peaks and valleys of your dotted cosine graph. Okay, does that make sense? So all the dotted lines you see is just to kind of help us know where to put the cosecant graph, or sorry, the secant graph. But it's not really part of the graph, but we graph it because it helps us know where to plot all the secant graph.
Do we have to plot the two on the edges?
Oh yeah, these we can drop because I just filled this out, but yeah, technically, if we're going from 0 to if we're going from 0 to 4 pi, it'll just be showing. Is that what you're asking?
Oh, should we still have to put half then?
Yeah, so technically it should be starting just like showing a half of the parabola at 0, and then it's gonna end with the first half of the parabola at 4 pi.
Pretty fun. Like the home.
Okay, so we're going to fill out period, domain, and range. So period is still 2 pi because it still takes 2 pi for the full cycle to complete. But domain is all real numbers except the asymptotes, right? So the asymptotes are just going to be pi over 2 plus pi n. So basically, if we start at pi over 2, we can just keep adding n pi, and we're going to hit all the possible asymptotes. So we say pi over 2 plus n pi, or plus pi n, where n is an element of an integer. Okay, any questions here? Okay, so the idea is that we are graphing sine and cosine because cosecant and secant just conveniently just branches off of the shape of our sine and cosine. But sine and cosine is not really what we're graphing ultimately, so that's why I want dotted lines there. Okay, it's not really part of the cosecant or secant graph. Okay, so let's go to Everybody good with this problem at the top? Let's go to number 1. If you guys can cross off number 2, because I want us to use the entire space there available for number 1. So number 1, it says y equals -3 cosecant, okay, theta over 4 plus pi over 8 minus 2. We're really just going to treat this like what? Sine. So imagine like this wasn't a cosecant graph. Just do everything from sine's perspective. Okay, and then at the very, very end, we can bring in the fact that it's a cosecant graph. Okay. So what's the first thing we can do here? So I'm just going to pretend like it's a sine graph and gather all the information that I can from sine's perspective. Okay, so I can factor my b value out. What's the b value? Just 1/4. So now we got to ask ourselves, 1/4 times what gives us pi over 8? So this is the puzzle that we're trying to figure out here. 1/4 times what gives me pi over 8? Pi over 2. Okay, let's try that. Okay, does that work? 1 times pi is pi, 4 times 2 is 8. So that's our c value there. Okay. So gather all the information. You guys just took this quiz yesterday. So pretend like as if you're gathering all the information from sine's perspective, right? So your a value, your b value. From the b value, find your period, your c value, your d value. Create your table, all the information that you're going to do. But when you graph, just graph dotted lines for your sine. Okay. And then we can work in the cosecant at the very, very end. Okay, so pretend like this is a sine problem. See how far I can get. Yeah, you can find it. A period is 2 pi over b. It's left. Formula is very much interval. Patience.
shift is the vertical shift is very last number.
Oh. And, so
Down to cross out too. You're going to all your work. It's almost pre-table graph as well.
oh, I did it.
So you're going to want to sketch graph.
What did you just do?
Okay, so here's the initial gathering of information for number 1. Period is 8 pi. Interval is 2 pi. So we can start at 0, add our increments of our interval. So 0, 2 pi, 4 pi, 6 pi, 8 pi. You know that your sine graph starts at 0. So you can build your sine graph 0, 1, 0, -1, 0. And then we can build in the vertical change with the amplitude. We can also bring in the fact that there's a phase shift. So we got to subtract every one of our initial x values with pi over 2. So now my new x value is negative pi over 2, 3 pi over 2, 7 pi over 2, 11 pi over 2, and 15 pi over 2. Okay, so we're just going to graph the sine based off of our sine graph based off of this. So I have my subintervals there, starting at negative pi over 2, then 3 pi over 2, then 7 pi over 2, 11 pi over 2, then 15 pi over 2. Okay. Remember, there's a vertical shift of down 2, so I have to make my dotted line at negative 2. Now, do you see where the cosine, sorry, do you see where the sine graph is going to cross the x-axis, or sorry, cross the d value? So to do that, we can graph our sine graph by looking at these values, right? Again, these values are just going to be distance from your dotted line. So that means at negative pi over 2, we're going to be right on the dotted line, be 0 units away from the dotted line. And then at 3 pi over 2, we're going to be 3 units down from the dotted line. So 1, 2, 3, all the way down to negative 5. At 7 pi over 2, we're going to be back to 0, back to the dotted line. At 11 pi over 2, we're going to be 3 units up from the dotted line. So we're going to be all the way up at 1. And then 15 pi over 2, we're going to be back at the dotted line. So now look where your sine graph touches the d value -2. Wherever those intersections occur, that's going to be where you're going to be dropping your vertical asymptotes. So vertical asymptotes should be at -π/2, 7π/2, and then at 15π/2. Once you drop all those asymptotes and the sign, then you should have an easy time graphing the true graph, which is what I have in blue. These are your cosecant graphs. Okay. Any questions there? So turn over to page 19, and I want us to do a secant graph. But we see the problem being secant, but we really want to do everything in terms of what? Cosine. So just pretend like as if it's a cosine problem, do everything from cosine's perspective, and at the very end, you can bring in those parabolas, which will represent the secant graph. Okay, but first things first, right? We want to make sure we factor that b value out. Okay, does anybody still need this page? Okay, number 7 on page 19. You can cross off number 8 so they can use all the space below for number 7 if you need it.
So we're doing cosine.
That's right, we're doing cosine now. We're doing cosine.
So just change that.
Yeah, basically you can do that. Change it out to cosine, and at the very end, you can bring in what the shape of secant is. So the first step I did was to factor that π/5 out. But now we got to figure out this puzzle, right? π/5 times what will give me -π/2. So there's my factored b value. I need to figure out what goes in this space so that when I multiply these together, I can get back to my original c value. Okay. Any idea what this number could be? Which is what? -5/2. Does that work? So the 5's cancel out. We're left with -π/2, right? So you just test a bunch of numbers or try different things until you get that to work, right? Okay, go ahead and find your information. You're really just trying to graph your cosine here. There's that phase shift to the right, 2.5. Bid out your cosine. You know your cosine starts at the max and works its way down, back up again. On your x-axis, you're going to mark off 5 x values starting at 2.5 all the way to 12.5. You're also going to draw a dotted line at negative 1.5 because that's going to be your new d value. And then you're going to count from that negative 1.5, 1 unit up and 1 unit down to get to your peaks and valleys of your cosine graph. Okay, so here's my dotted line at negative 1.5. I'm starting my pattern at 2.5 because I'm shifting everything over 2.5. And with my cosine graph, I'm starting at the peak, right? So I'm starting at 1 unit above my dotted line. So I'm going to start here at negative 0.5. Okay. Next interval over is at 5. So at 5, I need to be back at my dotted line. 7.5, I want to go 1 unit down from my dotted line. So that's going to take me down from negative 1.5 to negative 2.5. 7.5, I'll be back at 0. And then, sorry, 10, I'll be back at 0. And then at 12.5, I'll be back up at 1. So look at where the dotted line touches the d value. That's going to be where you're going to be dropping your vertical asymptotes at 5 and at 10. Once you have all your dotted lines in place, your d value, your vertical asymptotes, your cosine graph, then your final thing is to put in those parabolas, which is really the picture of your secant graph. And the asymptotes kind of tells you how wide to make your curve. And then the peaks and valleys of the cosine graph tells you how low or how high to make the vertex of your, I guess, parabola. Okay, let's try one more. This is number 9. Number 9, it's just like on the test where you're just trying to find your A, B, C, and D value. But instead of sine and cosine, you're just replacing it with secant or with cosecant. But you find everything the same way. Okay, your period is still 2 pi over b.
Is there any tangent?
There is. We'll do that tomorrow. We'll do tangent and cotangent tomorrow. That's the final 2 we have to do.
Are they hard?
It's a little different, but a lot of things is going to carry over. We're going to go through the same formula and pattern as before. But yeah, it is more strange than these other 4, so we save them for the last. But we're kind of building our way there. But a lot of things that we're using is going to carry over for tangent and cotangent. Yeah, that's right. Once you find that vertex, then you're just going to, you just sketch the graph along the asymptotes, and that's good enough. Yeah. So the asymptotes kind of help you know how wide or how narrow to make your shape.
Horizontal compressed means that it's longer than the.
Right. So it says, if you read number 9 says, we want a period that is half the length as the normal period. What's the normal period? 2 pi. So what's half of that? Pi. Yeah. So the new period you're going to be using for number 9 is just going to be 1 pi. 1 pi, yeah, or just pi. So since the period is pi, we go through the formula. Period equals 2 pi over b. We solve for b. B equals 2. They tell us what the c value is. They tell us what the d value is. So we just insert it into our secant function.
Oh, it wasn't asking you to graph.
Right. You don't have to graph it. Just write the equation. Okay. Any questions? Okay. Your homework is page 18, numbers 3 and 6. Numbers 3 and 6 on page 18. Yeah, you can cross off the ones that are next to them, so you can have space for just 3 and 6.
Good afternoon, Milton Eagles. The following are the bus change announcements. Students who ride bus 4531 will now ride bus 4890. Students who ride bus 4086 will now ride bus 4902. Students who ride bus 4261 will now ride bus 4133. Have a good afternoon, Eagles.